Yo, hey everyone, it's me again, it's Ryan, and we're on day 5 of Advent of Code. So far we have 8 stars, and we're getting closer to the goal of 50, which I don't know if that's possible, but we're doing pretty well. So as always, we're going to be doing this together. I'll be walking you through my solutions, and we're doing it all in the browser. So adventofcode.com, you can create an account if you want, and then if you want to mess around, I'm using Ellie app, which is allowing me to write Elm without having to install anything on my computer. So let's dive right into it. If you haven't already seen, there's a playlist for this, and that should be linked at the end of the video or somewhere in the description or something like that. All right, part 5. Hydrothermal venture. All right, so what are our elves up to now? You've come across a field of hydrothermal vents on the ocean floor. These vents constantly produce large, opaque clouds, so it would be best to avoid them if possible. They tend to form in lines. The submarine helpfully produces a list of nearby lines of vents, see your puzzle input, for you to review. For example, so this is the puzzle input here. I'm going to copy that. Cool. 0 to 9, 5 to 9, okay. Each line of vents is given as a line segment in the format x1, y1, to x2, y2, where x1, y1 are the coordinates of one end the line segment, and x2, y2 are the coordinates of the other end. These line segments include the points at both ends. Okay, so it's inclusive. All right, so an entry like 1, 1, 1, 3 covers the points 1, 1, 1, 2, and 1, 3. 9, 7 to 7, 7 covers, okay, got it. For now, only consider horizontal and vertical lines. For now, so there's always a part 2, and I'm like, does that mean they're gonna mix things up in part 2 with diagonal lines? We'll find out. All right, so those are lines where x1 and the x's are the same or y's are the same. So the following, so the horizontal and vertical lines from the above list would produce the following diagram. Okie dokie. In this diagram, the top left corner is 0, 0, and the bottom right corner is 9, 9. Each position is shown the number of lines which cover that point. Okay, got it. Or it's a dot if there's no lines that cover the point. The top left pair of ones, for example, comes from 2, 2 to 2, 1. Okay. And the very bottom row is formed by the overlapping lines. Got it. Okay, there's an overlap. So from 0 to 2, and then from 0 to 5 on that 9th row. To avoid the most dangerous errors, you need to determine the number of points where at least 2 lines overlap. In the total example, this is anywhere in the diagram with a 2 or larger, a total of 5 points. Consider only horizontal and vertical lines. At how many points do at least 2 lines overlap? Okay, cool. So let's get started. My instinct for this, it looks like we have to like parse this, and then we kind of have to expand it out to the points. So kind of see how they did, like they took this and then they expanded it out to these 3 coordinates. I think we're really just going to be keeping track of how many times we saw something at a coordinate. And I think a dictionary is going to be a great data structure for that. So let's get into it. Let me get rid of some of the things that we're not using. These are left over from the last video. And I cleared out the input and answer. I usually do that at the beginning of the videos, but I thought we'd save ourselves some time. And I just do it here. So we always start with the raw string input, and it's up to us to basically parse that string and turn it into stuff that makes sense. So we're going to start with the input. And as always, I'm going to trim that to deal with, there's like the new lines at the beginning and the end. Great. Okay. And then I'm going to use, Elm has a string.lines function. That just breaks apart your string into a list of strings, and each item in that list is going to be a single line. So here we have the first element's that, the second element's that, and right now it's still all text. So the next thing we're going to do is we're going to start mapping this string into a list of maybe the first step is just map it into like the start and the end. So I'm going to do a list.map, and then I'm going to say to start end. And so this is the first function we're going to make together. So to start end is basically going to take a raw string. That's going to be like the raw instruction we get. And what we're going to try to do is we're going to try to basically, I'll add a type annotation to help understand this. What we want to do is have a start coordinate and an end coordinate. So what is a coordinate? That's something we can make up, we can define above here. So a coordinate is something that has an x position and a y position. You could use a pair for this. You could also, I like to use a record. We did that in the last video and it worked out okay. Okay, so our goal is to try to get a start or an end. That might work, that might not work. So I'm going to use a maybe for now. Basically, like if we get invalid input for some reason, strings could be anything. So if we got like, I always use the example banana, we can't turn banana into start and end coordinates. So we'll have to have something to handle that case. So I'm just going to split the string on this. And so to give you some incremental like progress, if we do this, this is going to make no change. And then if we basically, do string.split on this, what we'll see is we've kind of isolated the pairs here. So now we have a list of lists, and each one of those inner lists has like our pair as a string. So what I want to do is I'm going to want to basically do a case on this where I'm only hoping that I have two. So I'm really saying I kind of want to match like the start string, the end string, and then hope that there's nothing else in the list. So if we have that, basically I'm going to basically use a map2. I'm saying basically, I don't know why. I'm going to use map2, and what that's going to do is that's going to take. So what we're trying to do is we're trying to take each one of these fragments and convert them into a coordinate. So I'm going to say like 2 coordinate, and then I'm going to say like the start string goes here. I'm just going to actually call this first and second. First string, second string. So we're going to try to take that first string here and turn that into a coordinate, and then we're going to try to take the second string and turn that into a coordinate. And what this pattern matching allows us to do is say if we get the first one and the second one, if we get both of those as coordinates, we're going to be able to return start equals the first successful coordinate that we get, and the end equals the second successful coordinate we get. And this here is just our start and our end here that we're trying to return. So that's what's going to happen if we do see only 2 strings here after the split. But if anything else happens, we're going to fail and say like we couldn't. Basically, we weren't able to get it. So what we need to do next, I'm going to format this, and Elm's going to let us know. It's going to say, hey, I don't know what to coordinate is. So we're going to have to implement that function too. So toCoordinate is going to take a string, and it's going to maybe return a coordinate, depending on if we are able to get 2 numbers when we split on the comma. So toCoordinate string, and then we're going to get a coordinate. So for now, I'm going to hard code nothing. Let's just make sure that we're getting nothings. Okay, cool. So basically, if all of them failed, like none would come through. But what we're going to do is something pretty similar here, where we're going to do. I'm actually going to copy this whole body, and we can add this comment back in. I like to disable the comments while we're working through it, so we can kind of incrementally see what's going on. Is this not going to do it? Okay. So what we want here is instead of splitting on the arrow, we're going to split on commas. And if we see that first string and the second string, we're basically just going to try to turn them into coordinates. So something cool about type aliases in Elm that I haven't showed you is that they're also functions. So maybe real quick, I can show you what I mean by that. This is a terminal I open up. I have Elm installed locally. And so Elm comes with a few commands. So it has like a few things, but we're going to use a REPL, which just allows us to kind of run Elm from the command line. So what I want to show you is if we take our type alias coordinate, and we say x is an int and y is an int, coordinate creates a nickname for that type, but it also, because it's a record, it also creates a function. that lets us just like specify coordinates like that. So what I mean by that is a coordinate is actually a function that takes the x integer, the y integer, and returns a new coordinate. So we're going to use that to our advantage when we use maybe.map2. Let me hop into the maybe.map2 function so you can kind of see why that might be useful. You see how map2, you can give it a function that takes like 2 arguments. So a, b to value, that's just like what we saw here in our terminal when we said coordinate. So the a is an int, the b is also an int, and coordinate. So if we can hand a function over that takes 2 arguments to map2, that'll work. So that's basically what we're doing here. If we gave this a type annotation, that would basically mean we wouldn't have to type all this out. So let me show you what that is. So if I said start end is this, then I could have also used that for my maybe map too. So basically, instead of having to type this function and getting like making sure this matches up with this and making sure this matches up with this, you can use start end itself as a function, and it works the same way. Let's see if I can just paste this right in the REPL. So if you see start end, that's also a function, but instead of taking integers, let me zoom in just in case that's hard to see. But instead of taking integers as its arguments, this one takes coordinates. Start end. And the order matters. So the first thing we give it has to be the start, and the second thing we give it has to be the second. So that's just kind of a fun Elm tip to save you some typing potentially. So let me compile. Okay, great. So toCoordinate is not what we want to call here. What we want to call is string.toInt. So string.toInt, we saw in previous videos, takes a string and turns it into a maybe integer, because there's a chance that that operation can fail. So we're going to use that. And what we're seeing at the end here is that we have the start is 0,9 and the end is 5,9. It's kind of confusing because end is being alphabetically sorted with start. So when we're looking at this debugging output, it looks like we have it flipped. But we're good. So the starting point is x0, y9, and then the ending point here is x equals 5 and y equals 9. So that's good. And we're doing that for all these. Let's clean up these justs by filtering out any failures. We don't see any nothings here, so it looks like all our parsing is working out, and we can just kind of discard that wrapper around it with the filter map function. So now I have basically a list of these starting and ending points. So that's cool, but what I think would be a good next step to do is to expand out the start and end into a list of coordinates. So I'm going to do list.concat_map, and what concat_map is going to do is it's going to, let's actually start with map, and then I'll show you concat_map. I'll show you the problem that we're going to run into as we do this, that concat_map is going to solve for us. So what we're going to do is we're going to want to take go from a start and an end record, a start end value, and we're going to turn that to a list of coordinates. So I'm going to say to coordinate list. Great. So we have a coordinate list here, and that's just going to be one more function that we make. So the coordinate list is going to take the result of the last operation, which is a start end. And what we want is a list of coordinates. So if you remember in the problem, we get a start and an end point. What this function is going to do is it's going to convert it to a list like this: 1, 1, 1, 2, 1, 3, and basically enumerate all the values that that line is creating. So let's see how we can do that. So start. And so here we can destructure the start. I'm gonna make some space here. Sorry, my nose is really itchy right now. I don't know what it is. Maybe my computer fan is kicking up dust now. Drink some water. Okay, great. So we have a start point and an end point. What we want to do is we want to figure out like how we're going to fill in the numbers. So if the puzzle said, let's assume that the x's and the y's are the same. So I have a feeling this is the part that's going to change in part 2. So if it's going horizontal, we can check to see if the x's are the same. If it's going vertical, we can check to see if the y's are the same. I'm going to try to think if there's a clever way for us to avoid having to be so explicit on the off chance that they're going to make us change it in the next step. So trying to be a little proactive, but I might be prematurely doing work here. Let me think. So we can ask, we can take the x's, the x values of both, and the y values of both, and we can basically get like the ranges in between. So maybe just knowing which x is greater or which y is greater will allow us to use the list.range function. So I'm going to start with this. I'm going to say there's an x range, which is a list of ints. Now the x range is going to work is if the starting x position is greater than the end x position. Then I'm going to make a range. There's a list.range function that comes with Elm, and I'll show you how that one works. We're going to go to the package docs, type in range, and what it does is it creates a list, and it's an inclusive list, which is good because that's what the puzzle was talking about earlier when I was saying like they're included. So if you call range with 3 and 6, you're going to get a list of numbers 3 through 6. This might be like a way you do this in a language with for loops is you would say like for I equals 0 as long as I is less than whatever, and you'd kind of like do the inserting yourself. Elm doesn't have any for loops, so this is how we kind of build up lists of just numbers. So what we're trying to do here is we're saying if start is greater than end, our range is going to start with the lower number and end with the higher number. And that's important because the docs here say that if you go in the other direction, we're going to get an empty list, and that's not what we want. We really want to make sure that the left number is greater than the right number. Oops. So we're going to do that. Oops. And then else, we're going to do the start x first and then the end x first. So this is going to make sure that our list isn't empty. And what's cool is that the start and the end are the same. You can even see the Elm example here. It's just going to create a list of one value, which is perfect for the sneaky thing that I'm going to try to do here. So this is going to be the exact same code. I'm just going to copy paste it. We could move this in a reusable place, but I don't think it's worth it at this point, unless we get a Z direction. I think for 2, it's okay to just do this as long as I don't forget to clean up all my x's. But you could imagine we could have a range function that took like the .y as an argument, so we could reuse some of this stuff. Okay, so I have an x range and a y range. Let me just kind of show you what those look like right now. So the x range, for example, for the first one is going to be 0 through 5 because it's a horizontal line. Let's look at the puzzle input and kind of try to follow along. So the x range here is 0 through 5. Here it's going to be 8, 0 to 0, 8. Are there diagonal lines? Oh, okay. It's saying ignore the ones where there's changes in the x and the y. So here we're just going to ignore that, and then like here we'd ignore that, but then here they're the same. So what we're going to do for our thing is we're going to say basically if so this is an example of the x range and the y range. Let me just sorry, I keep jumping around. Let me show you what it looks like when the x's are the same, right? So if we look here, the x values didn't change. We went from 2, 2 to 2, 1, and so that x value of 2 didn't change. So what we'll see is a list of length 1 if the values are the same. And the same goes for the y range. If we look at what y range is doing for each of these numbers, when the y value doesn't change, we get a list of length 1. So what we can do with this is we can say is horizontal or vertical. We can say is the length of the x range 1, or is the length of the y range 1? I'm going to hit format here to fix that spacing. Because if that's true, it's horizontal or vertical. then we know that one of them is horizontal. Sorry. So, okay. So the list length of the y range is that, and list. Okay. So what this is saying is that this line is horizontal. This one isn't. This one is horizontal or vertical. This one is 2. This one is 2. It's saying this one is not. So I'm following along with the falses here in case you're wondering where I'm getting this from. But basically the true is saying line 1 is basically a straight line. It's not diagonal or anything. So we're going to use this as kind of like a filter condition. So what I want to do is I want to basically use the x range, use the y range, and kind of fill values along like everywhere in between. So I think the way I'm going to do that is I'm going to say if I'm going to do it this way. So if the x range is 1, so basically if there's no changes along the x, what I want to do is map through the y range. And so for each y value, I'm going to make a coordinate. So I can just do this like this, where the easiest way to do this. Oh, okay. So if the y range is 1, then either I can use the start x or the end x. They're both the same. That's what that's telling me. And do that. And I basically want to do this for each number in the y range. Now I'm going to do something similar. And I'm going to say else if the y range is 1, then I'm going to loop through all the x's. And I'm just going to take the starts and the finishes, or sorry, the starting y point, because I know that it's the same, whether it's start or end. It doesn't change. And then if not, I'm going to return an empty list. So let's format this. So I'm going to leave this commented out for now, because we're not using it. Or actually, I'll delete it for now. That's an easy one to type again if we need it. But basically, what this is hopefully going to do is this is going to take things like 0, 9 through 5, 9, and it's going to enumerate all of them in order. So now you'll see that this has expanded out into like all the things in between. And for the diagonal ones that we're supposed to ignore, it's just going to do an empty list. And so what you might notice is happening is we're having a nested list of lists. And this is going to come back to why I was reaching for concat map. So now that we kind of see the problem, it's going to be clear why we want to use concat map instead of map. Specifically for this, we're going to want a flat list of answers. So let me search for concat map and show you what it does. So basically, when you run concat map, you have a function that instead of going from like an A to a B, it goes for like one value to another. It goes from one value to a list of values, and it just flattens the list for you at the end. So basically, if we use concat map here, that's the same as if we used map here, and then we just called list.concat and kind of flattened the results. So it's going to do the same thing that this does, which is just kind of merge the lists. But if we can do it in one line here with concat map. So it's like a little helper. But that's the same exact result we saw from using map followed by concat. So this is great. So we have a list of coordinates. What I want to do next, I'm actually going to change the implementation of coordinate so that we can use a dictionary with it. So I'm going to change the coordinate to, instead of being x and y like this, I'm going to use something called a tuple or a pair. So instead of this is no longer a shortcut. I'm going to use tuple.pair. And then here, instead of us saying x equals and y equals, we can kind of use the tuple shorthand here. And the reason I'm going to do that is because dictionaries in Elm can only take certain keys. And a dictionary is going to be really great when we get to the part where we have to count how many times we've seen something. Oops, this should be start y. Great. Okay, so excuse me. Start and to coordinate list. Okay, start.x and start.y. Okay, so now we don't have these dots, these .x's and .y's anymore. I'm going to make a 2x and a 2y function here. And 2x is going to take a coordinate, and it's going to spit out the integer. So 2x for the coordinate x anything, it's just going to be x. So we're going to ignore that second value, and the same is going to be true for 2y. But instead of grabbing the first value, we're going to grab the second. So this is 2x and 2y. And then instead of doing dot x everywhere here, oops, we're going to basically do 2x. I'm going to try to keep this code as untouched as possible. And the way I'm going to do that is by saying input, say start and end. And we're just going to leave the body of our code kind of unchanged. And how I'm going to get around this is by saying start has an x, which is the 2x of input.start, and y, I'll make a function called toRecord. That'll be easier to look at. Sorry, this is I'm kind of hopping all over the place, but I think this will make it easier for us to use the code below. We're gonna like basically convert our tuple. Instead of from a 2x and a 2y, we're just gonna have a toRecord, which is gonna convert it into that x and y thing that we had before. Great. Okay, so what this is gonna do is this is going to take x and y, and it's going to return x equals x and y equals y. So now we're back to the record. And the record syntax is really nice because we can just treat things like properties on the values. We can just say like dot x dot y. So that would be a bad copy paste problem. So what I'm doing here is I'm saying we're going to call this start end list of coordinates a tuple. Oh yeah, let me give this a different name. This is going to be the tuples. Tuples, pairs, these are all different words. Elm calls them tuples in the docs, so it's probably good that I introduce you to that name. Anyway, so now we've got this again. So this is what we were seeing before, but this is a little bit more dense of a format. Kind of matches more closely to what we see in the string. So yeah, that's actually pretty nice. Okay, so this is like coordinate stuff. I'm just going to move this down here. So I'm going to organize the code a little bit. Coordinate, start end, and then yeah, coordinates. This is like a way to go from a start end to a coordinate list. This is awesome. Okay, I'm going to just move this up. And then that's the last rearranging I'll do for now, I promise. Okay. Cool. So we've got all these items, but what I want to do is I want to basically what the problem is asking for is to keep track of how many times there's an overlap. So if there's an overlap, that basically means that we're going to have duplicate coordinates. So like 0, 9 is an overlap, 1, 9 is an overlap. Basically anything that repeats, that's an overlap. So 3, 9, for example, is not. That didn't show up in the puzzle. So the way we're going to do this is we're going to turn this into a count dictionary. So I'm going to make a function called toCountDictionary, and it's going to count dictionary. So basically all it's going to do is it's going to take our list of coordinates as is, and we are going to keep track of how many times we've seen a given coordinate. So the key is going to be a coordinate, and the value is going to be count. And so here I'm just going to make a type alias for count, so it's easy to remember what we're storing here. But really under the hood, that's just an integer like anything else. Any whole number. Okay, so we've got our coordinates. And what we're going to do is we're going to basically loop through them. And each time we see a coordinate, we're going to basically update the dictionary. And if there's no entry yet, we're going to set that to 1. So we're going to say, hey, this is the first one we found. And if there is an entry, what we're going to do is we're going to we're going to increment what we see there. So how this will work is we'll do a list.fold. Fold L, this is reduce in other languages. But basically how it works is it has this signature where you take an item one at a time, so like a coordinate. And then we're going to take our dictionary as we're building it up, and we'll give it the initial dictionary. So initially we haven't counted anything, so we're going to have an empty dictionary. And then we're going to give it our list that we're looping over. So if I did this right now, it would just say dict.empty. As you'll see dict.fromList get printed out here. Basically there's no entries yet because we never, each time we come through with a coordinate, we just return the dictionary as is. We haven't done anything yet. So what I want to do instead of just returning the dictionary is I want to update it. And the way we're going to update it is we are going to basically update the value at that coordinate. And this is going to be a function. So this is going to be update count dict. And what it's going to do, we'll define it soon. And this is a function that takes these 3 arguments. And I'll show you what update count dict does. It's going to take, there's maybe going to be a count there already. If we didn't find an entry, like if it's the first time coming through for like, I think like 09 was our first coordinate, right? So if we're going through this program, the first time we come through, this is going to be nothing. And basically what it's up to us to do is to like insert that initial like count 1 when we see that. So this is going to be maybe count. So basically we'll say case maybe count of, if we already have an existing count, that's great. What we're going to return is the existing count plus 1, right? But if no one has entered a value for this coordinate yet, we're going to just initialize it. Let's say, hey, this is the first one we found. We're going to return 1. So every time we get a coordinate, we're basically going to update this dictionary at that value. And that's what the dict.update function is going to do for us. So I'm going to run this. And what we're going to see here is that 09 has 2 entries, 14 has 1 entry. And now we have like a list of how many times we've seen each coordinate. And on top of that, we can pipe that into a function to only spit out the counts. And so dict.values is going to say, ignore all the coordinates you found. It was important earlier when we were grouping things. But for this part, we just want to look at the values. And what you'll see is like, there are 1, 2, 3, 4, 5 2s in our list. And so if we look over here, let's see if that's right. Yeah, so here they also found those 5 points. And that's these coordinates that are getting the duplicates. So far so good. All the test data that we're using and like the sample output, those are matching up really nice. So the last step to do is basically count the ones that are greater than 1. So list.filter, we're going to run that greater than 1. We'll just make a really silly function. It's not too hard. That's just return true if it's greater than 1. So if we have a number, return if the number is greater than 1. So now we're left with just the 2s, and the last thing we need to do is get the length of our list. And if it compiles, which it will, we should end up with the number 5. And that's what we'll put in the puzzle. So I think that's part 1. I'm going to save this as is. And I'm going to copy this so I can add it to the description below. So you can play around with this code and run it in your browser if you want. And so we do get 5. And what I'm going to do now is I'm going to get my puzzle input and see if our code actually works for a bigger data set. Cool. So that's good. Hopefully it doesn't blow up memory because this looks like pretty big numbers. Okay. So what we're going to do is we're going to put these numbers in, and I hope that I don't have any trouble. So I get 5,690. Let's see if that's correct. Hey, another gold star. So we're doing great. So let's continue on to part 2. How long have we been doing this for? So it's been about 30 minutes. We did it. Great. You need to get a drink of water. That's totally fine. I understand. I'm actually going to do that myself. But I'm going to click part 2, and we're going to see what kind of twist they put on the puzzle. And maybe it's going to be like including diagonals, which might be a little bit more of a headache to do the math to figure out what coordinates are involved. So let's click this link and take a look. Unfortunately, considering only horizontal and vertical lines doesn't give you the full picture. You also need to consider diagonal lines. Because of the limits of the hydrothermal vent map, the lines in your list will only ever be horizontal, vertical, or diagonal at exactly 45 degrees. So here, we're not going to discard the diagonals. So 1133 will expand out to this. And then 9779 is going to basically overlap at 8.8 and kind of cross that way. So at the end, we're going to see this, and they still want to know if it's greater than 1. So almost all of our code is the same. Now we have to write this weird stuff that determines like which direction we're going to start incrementing in, right? So let's take a look. Let's see how this goes. So what I'm going to do is I'm going to undo that. So we're going to go back to 5. And it looks like the example in this puzzle is 12. So if we can get the example output to say 12, we did good. So what I'm going to do here is I'm going to kind of delegate this else situation. Basically, if the range is 1, we'll do that. If the okay, so this is basically saying this is like the x doesn't change. If start.x equals end.x, this is an easier way to say that. Else if start.y equals end.y. So this is what we were doing before. I think that'll still spit out 5. I think we can also like move these into this because they're not going to be reused in the other things. I'm going to do that real quick, just so that we're not doing any work that we don't need to. So just quickly, so you can see what I'm doing here. We're just moving the code we had before and kind of changing our condition. When we get to the diagonals, I don't want to like enumerate all the diagonals into this crazy big grid and then not use those. So that's why I'm kind of getting rid of this. So if you want with part 1, you can take the part 1 example and do this also. I think it'll make it a little bit faster. Maybe not. But yeah, so I think when we get to diagonals, I don't want to like have like a crazy x times y thing going on. So what we want to do is we're going to want to say there's a few different conditions. And I don't know if I want to inline this all in the diagonal. So what I'm going to do instead of doing a crazy else if where we have to keep track is let's just cover all the kinds of diagonals that there are and kind of work through it that way. So there's a diagonal that goes from the bottom left. So from bottom left to top right. Then we'll do something here. There's that one. There's one where it goes from the bottom right to the top left. So these are both ones that go kind of up, either up this way or up that way. So I'm going to say that. And then there's 2 more, right? There's going to be ones where we're going to go from the top left to the bottom right. And there's going to be ones where we go from the top right to bottom left. So instead of from, I'm going to do is here, and we're just going to do some checks to see, to basically see which direction we should be incrementing things. And then we'll do it that way. So I'm going to take this. So how do we know if a line is going from the bottom left to the top right? Well, a line, and I'm going to give this the type signature of Boolean because that's what it is. So it's going from the bottom left to the top right. If the start dot, if the start dot x value is less than, it's going left to right if basically the x is less than, and it's going to go from bottom to top if the start dot y value is greater. What's weird about greater is that the greater numbers, I think, go down, right? So this would be like 0, 0, 9. So I think from bottom to top isn't actually what I'm thinking of. This is from top to bottom. This is where I'm going to get messed up. So if the y is greater means bottom. Okay, so yeah, that was right. So start is greater. So we're going to have that. We're going to copy this. And then instead of that, we're going to do if it's going to be the exact same logic, except we're going to go start x is greater than if we're going right to left. And then for these last two, it's probably a more general way to represent this, but I'm trying to be clear at the cost of concise here. Oops. So it's going left to right if that's less, but then these are going to get flipped. So I'll do that. And basically this is the same thing, except this is going to get flipped. So hopefully we'll see that there are 1, 2 of these, there's 1 and 2 of these, there's 1, 2 of these, and 1, 2 of these. So I think we've covered everything. So these are the different cases. So now what do we want to do? So if I don't know what's clear. I almost want to put them in the else if, because I don't want this logic to be too far from the code I have to write. So let me actually do that. Let me start with this. Or let me at least put it here. So if the start and the x are less than that, what we want to do is we basically want to increment. We want to add to the x as we go, and we want to subtract from the y as we go. So I'm going to say diagonal line, and we're going to give it the start, and we're going to give it the end. And what we're going to say is we're going to use the plus operator and the minus operator. So this is what's kind of it's going to be strange. So plus and minus means that we're going to be increasing in the x, and we're going to be bottom means we're going to be decreasing in the y. So there's going to be this function called diagonal line that we'll implement together in a sec. And then this one is going to go from right to left, so we're going to be subtracting. This one is going to go from the top left to the bottom right, so they'll both be increasing. And then this one here will be always increasing because we're going from the top to the bottom, that increases the value, and then minus because we're going from right to left. So what this looks like is actually a lot easier to read than all this nested XY stuff. But what diagonal line is going to do is it is going to kind of loop through the X or the Y direction, and it's going to call this like change Y, change X function. So let's just add a type annotation so we can see what these are. So if we look at add, and let's go back to the REPL real quick to get a feeling for add. If you do 1 + 1 in Elm, you're going to get 2, hopefully, right? But something cool about Elm is if you put parentheses around an operator, like plus or minus, you actually get a function. So if I did plus 1, sorry, so if I had like add is an int to an int to an int, I could implement that like this, or I could just say it's the same thing as this function. So add is basically an integer to an integer to an integer. So that's what we're going to do here. We're going to say there's some way to change. There's some way to basically change what we're going to do with 1. And then there's a way that we're going to change the x. So there's a way we want to change x. There's a way we want to change y as we go. So those are going to be that. And then what we're going to spit out as a result is a list of coordinates. So if I did this, this would compile. It would be wrong. It would still be 5. We want this to be 12 at the end, right? So what I'm going to do is I'm going to list.range from the, I guess there's like the low and the high, right? So plus and minus. We also want to know where we're going to start counting from. So what's the lesser of the two values? So the lower of, so if the bottom left, basically we want to have the smaller values here. So if I do that, that's start x and end y. So this is a little bit weird. So this is going to say the smallest. We're also going to keep track of what the starting point is. So I'm going to do that like this. And we can call that a coordinate too. Sorry for how confusing this is. So what we're going to do is we're going to basically give it a starting point so it knows what word we want to start counting from and subtracting from. Actually, I think I'm doing too much work. We don't need to do this. We can always use the starting point. And I think that's because we're doing this add subtract thing. So what we're going to do is we're going to basically loop through the difference between either of these things. So what that means is we're going to start with 1 in our range, and we're going to go all the way up to the difference, like basically the absolute value of start x minus end x. So this is just going to give us the distance between the two lines, always positive. So the absolute value function is if we did like 7 minus 5, we get 2, and if we did 5 minus 7, so no matter what order we put the numbers in, absolute value is going to make it so that number is always positive. So we're going to start here with this list.range, and what we're going to do is we are going to loop through it and increment as we go. So list.fold L. So as we go, we're going to take the number, which doesn't really matter. We can ignore that number. And what we're going to do is we're going to take the sum, and we're going to do sum plus 1. Or sorry, we're going to change the coordinate. We're basically going to keep track of a list of coordinates as we go. So these are actually this is our list of coordinates, of diagonal coordinates. And what we're going to do is we are going to this will be how far we've gone. So this will be our number. And so we're going to take our list and we are going to, I think we don't need to do a fold L here. We can just do a map. So we're going to take each distance starting at 0 actually. So starting at that, and we're going to basically do start. We're going to use our change x function. So we're going to do the starting x position, and then we're going to do our number. And let me just make sure that I'm doing the minus correctly. So if I did minus 5 and 10, that would give me -5. So if the bigger number is second, that gives me -5. So hopefully, okay, so it's just important that we are doing change y, the start y, and the num that we see. I think this is right. This is a little confusing, so we might need to break it down to get a better understanding of what this is doing. But let me format this. We'll see if this is clear. So we don't need that. No, it's 12. Okay, cool. So, all right. So let's move diagonal line into the terminal. Look, first of all, let's see if this is correct, and then if it's correct, let me explain what's going on here, in case anyone's lost. Because we kind of did a lot of stuff in that last step, and it might be easy to follow, but I'm gonna lean on the side of easy to understand here. So before I save this, I'm going to give this a new name. Make sure we're using our test input here. I'm gonna save that. Compile that. It's still working. And I'm gonna copy this URL. Oops, got the wrong thing here. I want the puzzle input. Good. All right, so that's that. Paste that, and then I'm gonna copy our link so I don't lose it. Great. So that's our part 2 answer. And we're getting 17,741. If this works, then we're all set, and I can explain what I did. Okay, great. It worked. Okay. So we kind of did a lot at the end there. That's day 5. We did it. But if for anyone who's interested, I'm just gonna go through kind of what this last confusing diagonal line code did, because we did an absolute value here. Maybe it would help to start breaking these apart into variables. So one thing we can do is we can give this thing a name. So the absolute value of the start x position and the end x position is like the side length of the diagonal. Like this is like the distance. It's hard to think. Let me draw this out with some ASCII art. So if I have a diagonal like this, where this is my grid, I'm just gonna make sure that, yeah, that's visible. So if my diagonal is going like this, it's going from here to here to here. And this is my starting position. This is my ending position. What the absolute value is doing, is doing here is it is saying, like, what's this number? Like, how far does it move? So if we can say it goes, from here to here. So I'm going to put a column number over the top so we can see. So if it's going from column 3 over to column 1, that means that this number is going to be 2. So what we're going to get here for a distance is going to be 2. So this is going to be the diagonal distance. Okay, so diagonal distance is just this, and this is just a number. So basically, if our diagonal was going like this, since we always know that the x position and the y position are changing at the same rate, because it said it would be a 45-degree angle, we can always just do the big number minus the little number. And what absolute value is letting us do is, even if the starting point was in the bottom right, so like let's say this was the start and this was the end, we can say that like 4 minus 1, that's positive, that's 3. But with the absolute value, we can say that the 1 minus 4 is also going to be 3. So this will always be a positive value, which is what list out range needs. And so what we're doing here is we're starting at 0 because we want to include the starting point, and we're basically going all the way to that distance. So using the change x and change y that were passed into us, we're basically incrementing or decrementing the x and the y as we go. So in the example, let's look at this example where we're starting in the top left and going to the bottom right. Okay, so for the top left to the bottom right, we're going to be adding to those numbers each time we go through. So as we start, let me kind of space these out, and we're just going to do this so that this is easier to see. So this is our y-axis. So what we're doing here is we're saying, all right, at the start, we're going to have 1, 1. And then each time we go through, we're going to say, take that 1, 1 and add 0 to it, and add 0. And so this is addition because we passed in addition for the top left to bottom right branch in our if statement. So each time you can basically think of this as like a plus, and you can think of this as a plus, right? So each time we go through, we're saying, okay, this time I want you to add 0 to both numbers. This time I want you to add 1 to both numbers. So 1 plus 1 and 1 plus 1, that leaves us with 2. So we end up recording this coordinate. And we do that, and for the add case, it's kind of easy to understand. But for other cases where we don't have this, we have like some things are going in one direction, some things are going in others. So in this example, we have increasing on the x, but decreasing on the y. So this example, it's not going to be plus plus. Oops. So when we do the change of x and the change of y, these functions, because we pass them into diagonal line, are going to be different. So this is going from the bottom left to the top right. So let's take a look at that branch. From the bottom left to the top right, this is saying I want you to add along the x as we go and subtract, so make the numbers go up along the y as we go. And that's what allows this to basically track here. So you always using the starting coordinate. With the start x and start y, we start with adding 0 and subtracting 0, so we're left with the same thing. And then the second time, we're going to add 1 and subtract 1, and that's what's getting us this coordinate here at x. And then we kind of keep doing that until we run out of distance. And when we get to the final distance, we're done. And that's how this code works. So that's pretty much it. If you have any questions, feel free to drop them in the comments. I'd love to help. You can reach out to me in the Elm Slack. I'll have a link for that in the description below. My name's just @Ryan. Yeah, feel free to subscribe to the playlist or whatever, like the video, if you like the video. And yeah, thank you so much for watching, and I hope to share more of these. Today was a fun one, so take care.